Below, the graph of the motion of an object is shown. The vertical axis represents the position of the object. That's where it's located. And the horizontal axis is time. So as time goes on, the position of this object changes. Now the first derivative of this graph would give us what is called the velocity of the object. So the velocity is the instantaneous slope. But we're also going to be asked about the speed. And so what's the difference between velocity and speed? Well, speed is actually going to be the absolute value here of the velocity. And so speed is represented by the steepness of the graph. So let's keep that in mind as we answer the questions. All right, first one says, at what points, if any, on the graph is the object's velocity zero? So one of the things we may want to do with a graph like this, because the curvature of it is constantly changing, is we may wish to draw several little tangent lines at all different points of interest here. That'll be a guide for us to tell us about the steepness and also the slope. And what we're looking for here are lines that go in the same general direction as the curve at the points in question. They're called tangent lines. Now, are there any places where the slope of the tangent line is zero? And the answer is, of course, yes, right here at B. At the peak there, the local max, we see that the speed and the velocity are both zero. There's one other point where we see where the velocity might be zero, and that is F. At F, the velocity of the graph is zero. Okay, so let's put those 2 points down as answers for A. Now, at what points is our object moving slowly? Here, we're going to be looking for places where the graph's slope is not steep. Now, I think at A, the slope of it is very steep. Like if I were walking along that terrain, I would think that A is a difficult part of the mountain to get up. However, I'd feel much better about walking at point C because the slope is a little more gradual. Once I get to G, I feel like that's also a steep section as well. So I think that of all the points, C and perhaps E have the slowest speeds for this object and the most gradual slopes. I'd put B and F, technically, because even though the slope is zero, we're actually not moving there. And it said, where are we moving slowly? So I won't put B and F. But certainly at points around B and F, it would be going slow. But I can only choose from A, B, C, D, E, F, and G in this question. So now let's take a look at where it's moving fast. I would say clearly at A. G is kind of close, but I do feel that A is steeper than G. At what points is our object speeding up? So for that, we're going to want to divide our interval into several sections. And there's certain points where I want to make these subdivisions, and I'll explain later, I'm sure, why I made them where I did. So from A to B, what's happening to the speed of our object? Is it speeding up or slowing down? So since the graph slope is quite steep at A and it's 0 at B, we're moving fast at A because we're changing a lot of position with time. But at B, we're stopped. So that would be a place where we are slowing. Now at B, we're at rest for an instant. But at D, we're moving a little bit faster. So we're actually speeding up from B to D. What about from D to F? Notice that at F, we stop moving. And so for that reason, we're actually slowing down. Finally, from F to G, looks like we're speeding up. But notice that that speeding up does stop here. Okay. Which points fall into these speeding up regions? Well, certainly C. And that's it. Where is our object slowing down? I would say clearly at A and E. And that's it. I won't include points B and F. The reason why is that at point B, for example, it's slowing down to the left of B, but it's speeding up to the right of B. So it's like, which is it? There may be some debate over what the right answer is there, but I'm going to say that it's neither at that point. Now, at what points is our object actually changing direction? Well, you're going in the positive x direction at the start. Then at point C, we're actually moving the negative x direction. And so B would be a place where we are changing direction. And so would F be. What type of point was point B? It's a local max. What type of point is point D? It's a point of inflection where the concavity changes. And what type of point is point F? A local min.